hopefully you've gotten the hang of writing the numbers in so both sides get balanced. That shouldn't take you terribly long, but it's a great practice to get some tricks down under your sleeves. And what you have to do is you kind of go one side, then you come back and you balance it, and you got to go to the other side. But just start from your left to the right. And that key about saying leaving anything that occurs in more than one element or one compound, like if it's spread across 3 compounds, leave that for last, and a lot of times that balances itself. Now, one of the things it's asking you to go back through the worksheet and then determine what kind of reaction it is. So let's just talk a second about the kinds of reactions that can happen. First, you can have something like a carbon-hydrogen compound that reacts with oxygen. Carbon-hydrogen compounds are like methane, butane, gasoline, all of those kinds of things. We all know those burn. So this is called a combustion reaction. And combustion is different than most of these others because oxygen comes and rips apart the molecule that it's reacting with and reacts with every single element in it. And we'll make a balanced compound based on their charges. If you remember, the carbon, for instance, is a +4, oxygen's a -2, so that's why that's a CO2, whereas hydrogen's a +1, and the oxygen's a -2, so that's why that's H2O. But every element, whatever its charge is, balances out with the oxygen when it reacts. So the oxygen literally makes a C compound and H compound. Now, sometimes metals will react and burn with oxygen, or single element will react with oxygen. That just comes out to be whatever formula is based on their charges. So that is a combustion reaction. Now you'd say, well, isn't that always a synthesis reaction? Oxygen and oxygen becomes one compound. Not always. Look at this; they became 2 compounds up there. Whereas a synthesis is taking several elements and jamming them all together into one compound. Okay, the most famous compound is, the example of synthesis is photosynthesis, where it takes CO2 and water and meshes them up into sugar for a plant, or starch that makes the woody part of any plant that's out there. So 2 things coming together to make one thing, that's going to be a synthesis, or 2 elements come together to make a new compound. And again, it depends on their charge before the numbers that get there. Decomposition was one thing breaks apart into 2, 3, or 4 things. It may break into more than just that. We'll have to just make a quick mention when you throw something into solution, like salt into water. A lot of times this would be an example of NaCl. When it goes into water, it disappears because the salt gets surrounded by water and the chlorine gets surrounded by water. But the difference is that these are still in the water. If you take that water out, those will still come back together. You'll grow that salt back together. They haven't chemically changed. So I do want to mention that these will become fundamentally different. Like usually one comes off as a gas or they become solid. You'll be able to see they physically look different than what they started from. But anyways, when one thing falls apart into 2, that's called decomposition. When one partner cuts in, it's like on a dance. When somebody cuts in on a dance and says, hey, we're gonna switch partners. So one person has to go out and sit out. That's usually a single replacement. So usually it's a metal goes in with something else that's got 2 parts and becomes new partners. Double replacement is where 2 couples are in and then they switch dance partners and they go out. So the A and the C are switching places. Usually it's caused when you have 2 things dissolved in liquids, and when you pour them together, one of the pairs doesn't like to stay dissolved in water. It's insoluble water, so it falls out. The other pair stays in solution, and so you'll usually get a precipitate. So we'll talk about those, but I want you to get some practice identifying several of these. I'll even go in for this first one, and we'll identify a couple together. So when you have hydrogen and oxygen making one element, 2 things together making one, this actually could be this is a good example because it really will burn. It's going to give off flame, but this could be a combustion. Or it could be a synthesis because you do only create one thing. So I would accept in that case, that's a good example of synthesis. What do you think this is? One thing breaking into 2. That's a decomposition. Okay, so on and so on. So if you just take those same rules, say one thing is jumping in with another, so that's decomposition. I can do this one synthesis. 2 things are becoming one. Although if you want to call it combustion, you're synthesis. Oops, too many I's there. You could call it combustion. And then this last one is 1 part. Here's this 2 part. Think of water. If you're never quite sure and there's water in the equation, you can think of water like HOH, and sometimes that makes it easier to balance as well because sodium is going to kick one of those H's out. So if sodium comes in and makes a partner with OH and kicks one of the H's out, this is going to be a single replacement, okay? So I think with that in mind, you should be able to get the rest of those. But I'll put a note on this video that that's just how do you determine the type of reactions.